Okay, so today we'll be discussing why predicting yield in the identification of mining and extraction of commercial ore deposits is vital. It is vital, I can tell you now, because a mine will not and cannot open unless a profit can be made. So, for example, an existing mining company may wish to expand one of their mines to build a new mine. So what they'll do is they'll test an area using a variety of methods. Probably the most common is drilling. Drilling is where the area they want to mine, let's say this is the area they're interested in, they're going to drill holes in it, lots of holes. And these holes are usually spaced about 500 metres apart. Now, what they do is when they're drilling, this is their ground here. Now we'll drill down. And the mine's likely to drill down as far as they believe there could be ore. So, usually anywhere from 500 metres up. So, and by drilling in different spots across the area that is to be mined here, they're going to get a rough idea of if there is ore in the ground, what ore is in the ground, how much ore there is compared to the amount of dirt and rock there is, that is the yield. So they'll work out the percentage of the metal they wish to mine in the ground. And what they do is when they drill, all the dirt's going to come up the drill. It's going to pile up here. So this is all that dirt they got from drilling. Now what they'll do is they'll go and test this. They'll test this dirt. And I'm going to give a demonstration later on how they might test the dirt. There's different methods depending on what the ore is, if it's a sulfate, if it's a sulf, if it's a oxide, all different methods for testing it. But mine will be extracting an ore which contains copper sulfate. Anyway, so this is all going to cost money. The drilling, that's going to cost money. And in the end, money is all mining is about. They have to make a profit. So they have to be able to pay for the drilling. They have to pay for our miners here. They have to get a wage, usually a fairly high wage. So you have to pay for the miners. You have to pay for any explosives in open pit mining. Because they use explosives to dig the hole. They have to pay for any machinery used to remove the material that's blasted or dug out. There's our dump truck. That has to have fuel. That again costs money. You have to pay for the driver. That costs more money. Then you have to pay for your fuel. Now, fuel wouldn't be as big a cost if you're close to a town, which is another factor. If you're, say, 30 kilometres away from a town such as Northparkes Mining Parks, it's not going to cost as much fuel to get, it's not going to cost as much money to get fuel out to the mine because they only have to drive the truck 30 kilometres to get it out to the mine. Let's say we're in Western Australia and the mine was 1,000 kilometres away from any town or large settlement. It's going to cost a lot of money to cart fuel 1,000 kilometres out to the mine than it will 30 kilometres out to the mine. And yeah, distance away from a town is often a large factor because when you start getting so far away from a town that people have to live at the mine, you have to pay for their accommodation, their food, insurance, or more insurance. So yeah, these guys just end up costing more and more and more. The further away from the town you are. So here's our fuel truck. Costing us lots of money. Electricity is obviously going to be a big factor because mines are going to want to work as often as they can, including in the dark. So electricity. More money. And if they're too far away from the town, if they're too far away from lines that are already up, often power companies might not want to put more power poles down just for the mine because it may not be financially viable and it'll just be a waste of money. So electricity, lots of money there. Water, normally mines would have their own dams, so that isn't much of a cost. Insurance. More money, lots and lots of expenses that go into mining. You have to pay all the management, the boss has to get some, or should use CEO. CEO has to get a fair cut. Shareholders, of course, have to get a cut. More and more money involved. Okay, so now we've looked at why a mine has to know the yield of the ore that it is mining in order to be able to start a mine up. We can look at how they check how much copper is in their ore. And again, the reason why all of this here, this all has to cost less than what the final sales of the copper being mined is going to be. That's why price of copper in the present market is a large factor. Okay, so there's why. Predicting yield in the identification and mining of commercial ore deposits is vital. It's because of all this. Now I'll give a demonstration on one way on which mining companies may test their yield for ores such as copper. Today we will be extracting copper 2 from an artificially made ore. This ore represents an ore containing copper sulfate, which is a very common ore that is mined throughout the world. Ores containing copper sulfate are also one of the highest yielding ores, so here is a picture of our ore. Next we will break off a piece of ore and it will be ground into a fine powder using a mortar and pestle. Once the ore is ground into a fine powder, it will be weighed to allow for a percentage of copper to be determined after the process is completed. The weight is 40 grams. The ore will be mixed with distilled water and heated over a Bunsen burner for about 5 minutes so the copper sulfate dissolves. The mixture of copper sulfate solution and waste material will be separated using filtration with filter paper. After decanting the copper sulfate solution off, we add another small amount of water to the waste and filter it to guarantee all copper sulfate has been removed from the waste. When the copper sulfate solution has finished being filtered, it will be poured onto a looking glass and left to evaporate. This is our solution 1 week later. The copper sulfate solution has evaporated, leaving copper sulfate crystals. The copper sulfate will be weighed. It weighs 8 grams. The copper sulfate will then be dissolved in a beaker with distilled water over a Bunsen. The copper sulfate solution will then go through electrolysis until the solution is clear, using a lead electrode as the cathode and a copper strip which weighs 0.41 grams as the anode. This is the solution going through electrolysis. After electrolysis, we see a build-up of copper on the anode. The new weight of the anode is 0.73 grams. By subtracting the original weight of the anode from the new weight, we can work out how much copper was produced from the ore. We managed to extract 0.32 grams of copper from this ore. The ore proved to be 0.8% copper. If I decided this quantity might be sufficient to open a mine here, I would begin to calculate all of the economic factors involved. This would then determine if the mine would be economically viable to open in this area.